Hey everyone, so we're going to continue our discussion about linear motion and introduce the next part, which is all about speed and velocity. Just like with distance and displacement, how we had these two different measurements that both talked about how far something traveled, we have the same thing here with speed and velocity, both pretty much talking about how fast an object's moving. And just like with distance and displacement, each one carries their own different pieces of information. They have very similar definitions with one slight difference. With speed, it's usually defined as the rate at which distance is covered. So, how much distance we cover in a certain amount of time. Typically, we usually also refer to total distance. Velocity, on the other hand, is the rate of change in displacement. So, it's how much our displacement changes within a certain amount of time. So here we can already see the difference between speed and velocity. One uses distance, the other one uses displacement. Now we already learned that distance and displacement fall within one of the two categories of either scalars or vectors. Distance is a scalar, displacement's a vector. Well, now that our definitions for speed and velocity give us that one is related to distance and one is displacement, we can now define that speed is going to be our scalar term and velocity is going to be the vector term because equations dealing with scalars make other scalars. Uh, a lot of times we can use speed and velocity interchangeable. In fact, velocity can sometimes be thought of as speed with a direction. However, it's important to note that that's really only when you're moving in a straight line, going in one direction. As I mentioned before, in that specific case, distance and displacement are the same. So it shows that speed and velocity will end up being the same. However, once you make a change in direction and it's noted in the problem, then it's no longer the same variable. The displacement changes, so the velocity will end up being different. So that's kind of important to remember about this is that majority of the time it's going to come and go, be interchanged with each other. However, every now and then you do want to pay attention once direction starts changing, whether you have to look at speed versus velocity and use distance versus displacement. Just like with distance displacement, they both have the same units because again they're measuring the same thing. Both of them are measured in meters per second. Typically, they're also both represented by a v. Now, because velocity is a vector, that means direction matters. And that also means that when we start plugging velocity into equations, not so much the equation that we're going to talk about in this video, but in the later videos. Actually, you know what? We will talk about a few cases with signs here, but in the later videos, especially, when we plug velocities into equations, we have to make sure that we give them a proper sign to denote that direction. If you recall when we talked about vectors, we said that when we multiply a vector by a negative number, it flips the direction, and that we can define positive to represent one direction, and then negative to represent the opposite direction. So here, a positive velocity means that it's traveling in the positive direction. Most of the time, the way things are going to be described is that the observer is going to be typically the origin point or the point of reference. So positive velocity would typically mean going away from the person or away from whatever the reference point is. Negative velocity obviously means that it's traveling in the negative direction. And again, that would also mean that it could be moving backwards or it could be moving towards the reference point. Both of those would be representing negative velocities. And then because velocity is a speed with a direction and direction matters, it's important to note that there's a difference between a constant speed and a constant velocity. Constant speed, that value doesn't change. So that's it. Constant velocity, on the other hand, has that extra added direction aspect. So not only does the speed have to remain same, but the direction has to remain the same as well. So whenever you see the word constant velocity, realize that that's a more strict confinement. strict constraints on the problem, saying that not only is the speed not changing, but it's also moving in one single straight line and not changing directions in any way. This will definitely play a part in the next video when we start talking about acceleration. Some brief terminology that I want to mention: instantaneous. So we have different types of speeds that are going to pop up. One of them is an instantaneous type speed. Uh, that's just a speed that you're traveling at a very specific moment in time. Speedometers, motion detectors, radar guns, these typically record relatively instantaneous speed, your real time speed. As far as when we use them in equations, this is usually going to refer to like the initial or final speeds, or like the speed at t equals 3 seconds or something. Those are instantaneous speeds. They're speeds at a very specific moment in time. One that we're going to talk about right now, it doesn't get brought up too much, but we could also have what's called an average speed. An average speed would be, there's two different definitions. Just like with an average test, let's say, or an average of anything, it's you add everything up, divide it by however many you get. That's pretty much the same idea here. So an average speed could be an average of all the speeds that you're traveling at all the moments in time, or a simpler way to do it is to take total distance and divide it by total time. So these are the two equations that we have for average speed. This is the change in your distance, change in your displacement, whatever you want to call it, divided by time. And then this is the initial velocity plus the final velocity divided by 2. So as I mentioned before, just like how you take an average of two objects, two tests, you add them, divide by 2. If you have an initial and final speed, you can find the average of that by adding, dividing by 2. This usually only works if you're accelerating at a constant rate, which, as I'll mention later, is pretty much what we'll be experiencing in most of these problems. One thing I do want to note, again, it doesn't really come up too much. As I said before, speed and velocity are represented by the same symbol, and x also represents distance and displacement. So it turns out that this one equation can be one of two versions. If we're using this to find speed, and I'm going to call this average speed, so I'm going to put a bar up here, then I have to make sure that the x in this equation is representing distance divided by that time. If, on the other hand, I'm using this equation to find an average velocity, then the x in this equation represents displacement over time. Like I said, when you're moving in a straight line, it doesn't really matter. You're probably going to hear me use speed and velocity interchangeably. It's just one of those things where if they have an object that's moving in a circle or moving in a weird path, and they say the phrase constant, or the what's the average velocity, you kind of have to pay attention to that and recognize that you're not doing distance over time, you're doing displacement over time. So try not to get too worked up on this, but like I said, because it doesn't come up too much, just note that it exists. All right, so here's the first question. Pause the video, work itself, and we'll go over in a second. All right, now when you're doing tests and calculations, at least for free response type questions, you want to try and get into the habit of showing work. Now that means something very specific in physics. So I want to actually show an example of what it means to show all your work. Now, the first thing that I always recommend with any of these types of calculation problems is to write down everything you know. That could be writing down what variables every number is. It could be drawing a picture. Basically, you just want to try to set up the problem to simplify it for yourself. So in this case, we're told the distance is 300 kilometers. Since they want my speed in meters per second, I'm going to just convert that into meters by plugging in 10 to the third for kilo. Then they also tell me the time, and they say that they want the average speed. So I'm going to use distance over time. I'm going to plug the numbers in, and then I get that the average speed is 83.3 meters per second. One thing I want to mention is make sure that you're getting into the habit of, when you're recording a velocity, noting whether you're talking about a initial velocity, final, or average, and try not to get them confused, because for the most part they are they're not always different, but if just because you have an average speed doesn't necessarily mean you have the initial and final, and vice versa. So, just want to be careful with that. This equation in particular is a very simplistic equation, but because it's so simple, it's very easy for people to misuse it. So right now, I'm going to give you practice with it, but later down the road, when I give you more kinematics equations, one thing I'm going to say is that I do not want to see this equation unless you're either A, being explicitly told about an average speed or velocity, or you're dealing with something that's moving at a constant speed or velocity. Those are really the only two scenarios where this equation works: when they explicitly say the word average, or if they explicitly say constant speed slash velocity. All right, here's the next question. Pause the video, work itself, and we'll go over in a second. All right, so again, writing down everything that's given to us just so that we can identify what the main equation would be. The total distance that we travel is 60 kilometers. We travel this in a total of 4 hours. And again, they want the final, the average speed. So we do v bar equals distance over time, plug our numbers in, and we get 15 kilometers per hour. For part B, it's the same thing except we convert everything. So the 60 kilometers becomes 60,000 meters. Time becomes 14,400 because we're taking the 4 hours and we're going to multiply it by the 60 minutes, which are in an hour, times another 60 seconds, which are in a minute. And this will get me the total number of seconds within 4 hours. Once again, we use the same equation, plug the numbers in, and we get 4.2 meters per second. Two things to note. One, to give you kind of an idea of how fast this is, if you want to approximate these numbers into miles per hour, it turns out that meters per second is, well, if we take a meters per second and times it by 2, we'll end up getting about the amount of miles per hour something is. So 4.2 meters per second is about 8 miles per hour. And similarly, if we have miles per hour, we can actually estimate kilometers per hour by essentially doing the same thing. Again, good thing just to kind of have a grasp of how fast things are going in these problems, that you see meters per second, you can double it. You see kilometers per hour, you can half it. In addition, you can also use this in the real world. When someone's talking about kilometers per hour when they're from Europe, you can actually have a vague idea of how fast that is. One thing I do want to point out is the bad way of answering this question. So one way that someone might answer this is they'll try to do this. They'll do the 50 kilometers in 3 hours to get a speed. In this case, that would get you a speed of about, I'll just round it, 17 kilometers per hour. Then they would do 10 divided by the 1 hour to get 10. Then they would take this and use the version where it's initial plus final divided by 2. Do 17 plus 10 over 2. And they would have ended up getting 13.5. Now you may notice that is fairly close to the answer, but it's not the same. The reason why this is bad is for the exact same reason why you can't take a homework grade that was 100, take a test grade that you got a 60 on, and say that your average grade in the class is going to be an 80. Just like with most scenarios where the homework and tests are weighted completely differently, same thing applies here. This 17 miles per hour goes on for much longer than 10 kilometers per hour. So when you take an average, if you do the average like this, you're assuming that these occurred for the same amount of time, which they didn't. So if you were going to do an average like this, and you had a scenario like this, you'd have to do what's called a weighted average. I don't expect anyone to know how to do that or want to do it, as it is kind of, annoying to do, which is why I highly recommend not doing that. If you have information of distance and time, use distance and time to do v bar equals d over t. One equation, that's it. You shouldn't have to, you know, combine multiple equations in all these different ways. And that's pretty much it. We'll talk about the relative velocity in a second. If you have any questions, let me know. Otherwise, good luck and have a great day.